Hello and welcome. In this video, we're going to be going over two of the homework assignments that we have. Basically, in the beginning of the semester, you're going to do the simple and complex part one, and then later in the semester, you'll do part two. Okay, what you'll be doing for the first part is you'll be finding a part that you think is simple and a part that you think is complex on Thingiverse. And then you're going to write about why you think they are complex or simple. Okay, so for part one, you do not need to print anything. Okay, however, in this video, I'm going to go over basically how to do parts one and parts two. Okay, when I made this video, I was able to find the nut and the bolt, which is sort of the example I used as a part that is supposedly simple. Okay, now the clincher is, I guess, the nut and bolt isn't really that simple to print. It's just something that like might appear simple to someone who, maybe doesn't have a whole lot of experience with 3D printing. And then the complicated part is, obviously complex. There's a lot of parts that have to fit together. It's a drill chuck. I'll show you other photos of what it's supposed to end up looking like. Basically one part that you think is simple now, and one part that you think is complicated now as well. And then you'll write about why they're simple or complicated. And then later on, after you've learned a good amount about 3D printing, you're going to go ahead and print them. And you're going to say, okay, what I thought was complicated initially was actually simple, maybe, and what I thought was simple initially is actually kind of complicated. Okay. So the way you're going to do this, again, you're not going to model anything yourselves. You could go on Thingiverse. Right now I went to thingiverse.com. All right. And you could just type in, I just found a nut and bolt set here. So I could download these files. All right. There we go. Downloading. There we go. That is just downloaded, and then we'll go to our other tab. So X out of that. If my banner would get out of the way really quick for me. There we go. So this is the complicated part that I've chosen. Okay. And yeah, basically it's a larger chuck for a drill. So you can see kind of complicated the way it goes together. It has like these beveled gears, once you rotate those, it tightens and loosens the chuck jaws, because this larger beveled gear is going to be attached to this spiral thing, or they are one part rather. Actually, I think you bolt those together. But anyways, you have that the spiral that's mounted to that larger bevel gear, and inside those spirals, the chuck jaws go in those spirals, and then obviously as you rotate the spiral, the jaws will open and loosen. And you could see several pictures of how it went together. Use bolts to put it together, and if you have something that bolts, I can supply those most likely. So yeah, again, this is what I chose for my complicated part. So let's download the files of that as well. Okay, it shows you advertisements before it downloads. There we go. So now I have both of those. Let's go ahead and go to our downloads folder, and I'm just going to quickly extract both of these. Okay, there we go, and extract the one with the nut. Okay, great. So now we could go to Cura, and I'll show you how I would lay each one of these out on a bed. And then I'll show you like, how to slice them individually. So let's open up Cura. All right. If you watched the previous video, I showed you guys um, how to download the correct Cura, and also the profiles for the Prusa Mini. Might need a time lapse here. All right. So great. Now we're gonna go file, open projects, or not open project. I didn't want to do that. I want to go to file, open files, and then we're gonna go to the downloads, and then we'll start with the nut. So let's see what we have here. So I'm gonna go for just printing like a nut and a bolt. So let's take a look at the files. All right, so 25 by 8 socket, and let's try the the nuts as well. Okay, so that one and that one open. So yeah, I'm gonna put these like that on the build platform. All right. I'm going to show you some settings also to put these in. So as you're doing this slicer, I'll show you some basic things about this for these first parts. I have it on like sort of an advanced settings list here. Okay. And basically I could go here and I could go to very basic, and it only allows me to change certain things about what we're messing with. I'm gonna keep everything basically the defaults that it told us in terms of the wall thickness, the top and bottom thickness, and the infill. All right, but what I would suggest is that we change certain things about the material and the speed that material speed and build plate adhesion that will allow us to have greater success rate in our prints. Okay, so printing temperature, I would recommend going anywhere between 210 and 215. So I'll set mine to 210. Usually that works pretty well. The speed, as you can see, it sets you a single speed here. But if I go to the advanced menu, so if I go to advanced, it gives us more options for the speed. Okay. So there we go. We have a lot more speed options here. So what I'll sometimes do, so if you look, it has the printing speed that's like most of the print will be done in this speed, but you can set certain portions to be different speeds. So if you have the wall speed is different than the infill and the normal print speed. And then outer wall speed, inner wall speed, it speeds that up. So if you wanted to change any of those, you could. What I'm going to change though is the skirt slash brim speed, and that will by default change. Sorry, the initial layer speed, which will by default change the skirt slash layer speed. Yeah, if you bring this down to like 20, I find it works a little bit better, or even 15. Going really slow on the first layer helps you get good at bed adhesion. So I sometimes recommend slowing that down there, and that way you don't have to do it manually. All right. Um, for this one, we're going to attempt to do it without support. As you can see, we don't have a lot of really severe overhangs. And I guess we do have a couple of overhangs that are really severe, or just one in the socket hole for the bolts. Um, but yeah, that I'm not too concerned about. It can do small spans without having any support. So we're going to attempt to do the nut and bolts like this. All right. So what I could do here, I could do a number of things. I could slice this. And then slicing it, okay, looks like it's going to take 26 minutes. It gives you an estimate, tells you how much filament it's going to use. It's going to use like a little over half a meter and 2 grams of filament. That's cool. If I wanted to now, I can preview this. All right, and it shows me what it's going to do layer by layer. All right, so you can see what it's doing with the infill and what it's doing with all the walls and everything like that on both of those guys. So you can see it's making it hollow on the inside, and that's why the 20% infill basically has 20% solid space and 80% empty space, basically. So yeah, that looks pretty good. I'm totally fine with slicing this and printing it, but we will deal with the chuck as well. So let's go save project. I'm just gonna put it on the desktop. Nut and bolt. Save that. And then cool. That looks pretty good. Oh, and something I could also do, I forgot to change the build plate adhesion. So instead of doing a skirt, you could do a brim. So the brim, we could slice it again and we could show you just what it's going to do. And you can see it gives like it makes like rings around your part. And basically, it gives you kind of more surface area for the parts to like stick to the build plate, which usually results in a more successful print. Okay. So yeah, let's just make sure we save the project and we'll save it and override that. Yes. Okay, cool. So now what we're gonna do is we'll go to um the get a new project open and we will do the drill chuck stuff. Let me just X out of that just so I could give myself a little bit more space. All right, let's put that stuff in. So we're going to go to open files. We're going to go back to downloads to the three jaw chuck files. We need all of this stuff, I think. And let's see what we can do. Okay, cool. It put it all there. Doesn't have a whole lot of space. So we're going to be able to do this in a couple of different runs, or we're going to have to, I should say, do this in a couple of different runs. On the picture, I had sliced it on the Ender 3, which is what I have at home. So yeah, basically, we're going to need to move some stuff around. Let's see how many will fit on one. Okay. So we have, yep, face housing. Let's make that fit on there maybe if we can. We can also put the jaws out. Okay, cool. All right. Let's also put this guy up a little bit. There we oh, I think it's gonna collide with the other part. There we go. That looks perfect. Got a little bit of space. All right. And now doing that. Okay. So it looks like that'll actually be pretty good. Oh, and why not? Let's put this gear over here too. All right. So we need the gear, the uh the scroll, and the face housing in the next one. Okay. So we'll de delete those out of this one. Okay. And then we can slice this. All right. Um, For this one, I might actually increase the infill percentage to 50% because it's, I want it to be able to grab onto you know, grab onto things. So we're going to make the infill, we can move that up to 50. All right. So what I also see here, it's probably not going to be too severe, and we might even get away with it, but support material. Something I haven't really talked about too much yet. But basically, if you look underneath here where my mouse is, you could see that there is going to be a portion of this that doesn't have anything under it. Okay. That might be actually all right on this particular part, just because that span is very short. In other homework assignments, we're gonna do like a test print where indeed it does do unsupported spans just to test the limitations of your machine. But yeah, something we might consider is support material. I'll look underneath the parts like that. And they might actually make it. It does look like these like counter bores or whatever you call them um are going to be sort of unsupported and you might want to put some support on there. So I'll show you how to generate that. So you could go here and you could go to support and you could click generate support. And there's sort of normal support and then tree support. So like the tree support one basically is like sort of an organic looking one. Makes everything look like tree stems. Probably won't be able to see the full extent of tree support when I slice this particular part. But yeah, we'll just leave it as the normal support. I'll show you the tree support afterwards. So let's slice that. Okay, cool. 19 hours. Yeah, it'll take a while, I guess. Um, but yeah, indeed, it will. Uh, Yeah, it won't be too bad. Okay. And then also what I'll do here is just double check all my speeds and feeds. So looks like some things may have changed. So I'll make sure the temperature is up to sorry, not 220. I'll start with 210. And then I will go and make the skirt and brim speed as well as the initial layer speed be 15. Sorry, not 150. Make those 15. And then instead of a brim, yeah, we're going to keep the brim. That's what we're going to keep. Okay, cool. And we will slice that. All right, let's take a look at what that looks like. All right, cool. And you can see there is some support. That's that kind of blue stuff. You could see it is going to build up some support, especially yep, underneath where those guys are. So and last but not least, we are going to go to File, um, and we are going to save project. Okay, I already named this jaw one, so that's what we're gonna call it. OPM jaw, um, jaw two underscore one, I should say. So that's what I'll call it. Save. All right. Yes, override. Okay, cool. So yep, that looks good. All right. And next we will open up the other parts. Okay, and then we're gonna open up the files that we missed from before. So the housing, uh, the Uh, the gear ring and the scroll. Oh, the scroll. And actually, come to think of it, I think I need two more of the drive gears. I think I actually need three of those. All right, cool. So let's see if we can get all this to fit. I think I should be able to do it. So move that guy like that. Okay, that looks like it's going. Might need to even have three for this. Hmm, moving things around. Not the end of the world if it has three, but we are going to put a limit on how much material you could use. Like, if you have to have like two or three build volumes, that's probably okay. But we'll probably set the limit at like, three or so. Looks like I'll be able to do this in two. But yeah, if you need to use three, that's probably okay. But um, it ends up being a lot of material. There's no course fee for this course, so we're kind of just giving it all to you. Okay, great. So I'm going to print another two of these just because I think I need those three gears in total, and the other build platform already has one. Okay, so great, and I'll make sure we go back to um oh, let's change that to 15. Let's change the build blade adhesion to brim. Let's change, yep, changing the temps. I think I forgot to change the temps on the other one. But yeah, make sure everything is 210 before you start. And yeah, that should be good for changing that. Oh, and I wanted to make these have a higher infill percentage up to 50. And I'll slice. All right, cool. So this will take a day. That's kind of a long time. I could reduce the infill percentage if I wanted to reduce that time. But yeah, we don't want you to like, tie a machine up for like 3 days total. It looks like the total printing time for my simple and complex parts will be probably a little bit too long. So you know what? Let's reduce this to 40%. Okay. Oh, 40. There you go. Slice that should take us about a day now, hopefully, or less than a day. Okay, so a day. I'm also going to change. I could also change instead of fine, I could change it to be the draft size. And we're going to keep the changes that we made. All right, and let's slice that, and that should do it much faster. Okay, so that's 18 hours. Okay, that's much better. And just a couple more things before we slice. Yeah, we could increase the infill. Let's just make sure that's increased up to 50. Not 500, 50. Yep. And we're also going to generate support on this one, and I can show you the differences between the tree and the normal. So you have a support overhang angle here. If you do tree support, I could slice and show you what that looks like. I showed you what the normal support looks like on the one from before. Slice quick enough. I don't really think that these parts are going to need it, apart from maybe the this like circular hole here on the sidewall, because that might be a span that's long enough to where it'll need to be supported. And yeah, as you can see, those blue sort of limb-looking supports go up underneath there, and then yeah, it looks like the bevel gears look like they want support as well, but then not a whole lot else really is going to get support. Some areas underneath there. So that's tree, and I can show you a good example of tree versus normal. We'll need to reslice it to regenerate the preview. Well, this is slicing. I'll get a drive. Okay, cool. So that is sliced. All right. So yeah, now what's left to do is to save all these files to a removable disk and send it to the printer. Okay, just a couple of other things. So now we're ready to save this to a removable drive, but something I've been sort of not talking about. So I did not talk about our material and our nozzle size. Okay, so just before we go, you know, it depends on which machine you're on. There might be PETG loaded into it. Typically, I think I mentioned earlier in the video, I like to usually have PLA on these machines because they are kind of more reliable, even though the material strength of them is slightly less than PETG. So yeah, I like to keep PLA, but there could be PETG as well, and you could also have 0.6 millimeter nozzles. All right, so the way you would change that would be the line width. Okay, so right now we have a 0.4 millimeter nozzle. Okay, and basically that will work well with a line width of 4. Okay, and as far as PLA is concerned, that's where we set this the temps up to 210, and that that's how we basically account for that. PETG will need a higher temperature. You probably want to be up in the 235 range or something like that, and it'll give you more information on the spools for when you do go and print that. Okay, so right now I plugged a flash drive in, and then on Cura it'll say save to removable drive, so we could go ahead and do that. And I could eject it. So yeah, I have my drive here. This is going to be a 28-minute print, and I cannot stress enough, try your best to modify your slices in whatever way you can to get like everything down to be really under 48 hours. Really, if you can get it under 40 hours, that would be even better. But there are about 8 printers, and there's usually, well, the semester that I'm filming this, there's about 11 students, and I expect that to increase. Hopefully, we will also increase the number of printers, but I think we're going to end up increasing the number of students at a higher rate than we increase the number of printers, just because of space limitations and stuff like that. So I don't want these taking a very long time. You should know about this project, from about the first week of class or so. So you could go ahead and start printing. Certainly for the first portion of the assignment, you don't need to have the prints done. I think it ends up being, a few weeks after that part two is double check Canvas. But yeah, for now, we'll take the flash drive that we ejected and we will go and we will slice it. Oh, sorry, we'll go and we'll print it.
All right, in this portion of the video, I'm going to go over the actual physical printing process. A couple things you want to be aware of. You have the 0.4 millimeter nozzle here. I didn't mention it so much in the other part of the video, but all the settings that were like sort of for default are going to be for the 0.4 millimeter nozzle. And yeah, it should have set it somewhere on the screen when I was doing the slicing and everything like that. But we are going to be using the 0.4 millimeter nozzle. That is going to be the standard one. And it's like in 0.4 millimeter nozzle correlates to a 0.4 millimeter line width, which is what we had everything set at from before. So you could double check that if you'd like. Also, I want you to make sure that there's PLA on there. See, this is the Polylite PLA. That's what all of these like temperature settings were for. Other materials we might have are PETG. Okay, so you can, I don't have a problem if you print in PETG. PLA is like, unanimously, I would say, the kind of most reliable material, although PETG is definitely stronger and like, it's what they normally print in the hub, but for this class, since we're just learning and, part quality isn't really of the highest importance, PLA is kind of a more successful print. All right, so around the back here, you're going to see the USB port. So I have the USB that I put the G code on, that I put the slice on. I'll be able to plug it in there. Okay, so yeah, it already picks up the nut and bolt thing that I want. So I could click print on that. All right, and it should be starting up. So yeah, I already had the build plate heated up just a little bit, and I'll try and stick around so that we could watch the entire print. Well, not the entire print, but at least have it start, which is what you guys should do, and we'll talk through what it's doing. You could certainly skip through a lot of this if you want, but the nozzle's heating up. I'll film it in real time so that you guys could actually see what it's going to be like as you're going to do it. But yeah, nozzle's heating up. All right, something I didn't go over, I'll have another video for this, but there is a Z height calibration that you want to do before everything prints. I'm pretty sure that this one will be doing just fine. Nothing has really been changed from like the nozzle offset, but it's going to do a quick little offset with its proximity sensor that it has. And it's going to go over and like kind of probe various parts of the build plate. See, there's that like black thing off to the left hand side on the head there, and that's like a proximity sensor that can basically tell how far something is away from it, and it knows the offset from the proximity sensor to the nozzle, and so it'll be able to lay a first layer at the correct height and get the right smush so that it adheres to the bed. All right, cool. Looks like it's probing everywhere and getting itself a preliminary mesh. All right, and now it looks like it's going to do its purge line. I think it will do its purge line. Oh, no, it is heating the nozzle. See, there we go. It's heating that up. That needs to get up to 210, which is our preset speed. Okay, it should be noted that if I wanted to, I could tune this on the fly. So I could go over here to tune, and I could go here to print speed, and it says 100. We'd set nothing to have a numerical value of 100. That's a percentage of its like preset speed. I could also change the nozzle temp. I could change the bed temp. But yeah, it looks like it just did its purge line. That's what that one is. And it looks like it's sticking pretty well. Coming up a little bit. Let's see how that one goes. Looks like the outer brim is sticking. All right, that's looking pretty good. Felt like maybe the purge line that I pulled off was a little bit loose, but you know what? We'll give it a chance here, and it'll be stuck down with a lot more surface area. And in the middle of the bed, it's probably a little bit higher temperature, so it'll definitely help it heat up a little bit more. Okay, so yeah, that's pretty much it. I'll cut here, and then later on I'll show you how everything is printed, and I'll go over how to pull it off of the build platform. All right, so here we are once more at the nut and bolt. So we're very simply going to take this off. They pry off very easy, it feels like it. I will probably, let's see if I could use my finger to pry that. Very good. Oh, wow. And in this case, the brim came off very easily, but usually, you could just, peel that off or use some pliers or something like that. Oh, wow. And it looks like this particular nut and bolt was made with a lot of clearance. This has a lot of wiggle room there. Other nuts and bolts might not be quite the case there. And even though this fits on there, I don't really super like the compensation or the tolerancing, so it wiggles around a little bit too much for me. So I guess if I really wanted to perfect this, I would run it again, but this is going to be fine for an example of a simple part. So yeah, before you print it, you definitely want to write about why you think this is a simple part and why your complex part is a complex part. But then for part 2 of the assignment, you're going to print it and then tell me what you didn't or did like about the printing process and what was easy and what was hard. All right, so that concludes the video. I'm not going to show you how to start the complicated print because it started exactly the same way. So yeah, thank you very much for watching.